For us humans, it's nearly impossible to imagine a lifeless Earth. It's something that we all take for granted. Life on Earth has existed for almost 4 billion years. But over the course of history, life has undergone 5 periods where at least 3/4 of all the unique species at the time vanish into extinction during a short geological time. This is known as a mass extinction. A mass extinction can basically be thought of as a short period of time where a large percentage of species and biodiversity disappear into extinction. It's important to mention that geologically speaking, a short time may span anywhere from a few thousand to several millions of years. Comparable to us, 1,000 years sounds like forever, while to the Earth, it's barely a blink of its 4.5 billion-year-old eyes. The last mass extinction happened 65 million years ago, which wiped out the non-avian dinosaurs. It's nothing unusual for animals to go extinct. In fact, 99% of the species that ever lived over the course of history are now extinct. There is a natural rate of extinction called the background rate. Normally, we would expect to see around 10% of species going extinct every million years, 30% every 10 million years, and 65% every 100 million years. Mass extinctions occur when conditions on Earth change so drastically that most of Earth's species cannot adapt in time and die out. You might be wondering, if mass extinctions only occur every tens to hundreds of millions of years, why is this topic very relevant to us today with our tiny insignificant lives? After all, it's not like any of us are going to live anywhere near enough to worry about a mass extinction. Well, not so fast. Aside from the fact it's simply interesting knowledge, many scientists are claiming that the 6th mass extinction is well underway. Not because of volcanoes or giant asteroids slamming into the Earth, but by a single species. I wonder who it is, causing havoc with its only home. But before we dive into the science of the 6th mass extinction, let's explore what previous ones terrorized life on Earth in the past. The first mass extinction was called the Ordovician-Silurian extinction, which occurred 443.8 million years ago. It marked the end of the Ordovician period, which saw the very first terrestrial plants. The extinction is believed to have been linked to a phenomenon called silicate weathering. Silicates are minerals in the Earth that store carbon dioxide. The theory goes that the silicates absorbed so much carbon that ice sheets began to form. Once the ice had physically blocked the silicates, carbon built back up in the atmosphere, causing temperatures to rise again, which melted the ice, exposing the silicates once again. This cycle repeated itself again and again, and would have caused extreme climate shifts that resulted in some 71% of species disappearing. The next mass extinction happened 372 million years ago, called the Late Devonian extinction. It wiped out around 70% of all species at the time. It is one of the most least understood mass extinctions and took place over a very, very long time, over 20 million years. This meant the extinction rate during this time was only slightly higher than the background extinction rate. The two main theories of the cause of this extinction are climate change and oxygen deprivation. This is thought to have been the result of rapid growth and diversification of land plants, which generated rapid and severe global cooling. The emergence of plants onto land would have resulted in massive amounts of nutrients being released into the ocean, igniting massive algae blooms, starving the water of oxygen. The third mass extinction was by far the worst and most devastating to life, demolishing some 96% of marine species and an additional 75% of terrestrial species. The exact time span is unknown, with some scientists thinking it took 15 million years to others believing it took only a few tens of thousands. The most probable cause is severe climate change due to rapid global warming caused by a sequence of volcanic eruptions called the Siberian Traps. Global temperatures were believed to have soared by over 10 degrees C. Additionally, elevated carbon and sulfur levels from the volcanoes caused ocean acidification, acid rain, and other changes in ocean and land chemistry, devastating both marine and terrestrial organisms. The fourth mass extinction is called the Late Triassic extinction, which took place around 208 million years ago. A gradual change in the carbon cycle due to volcanic activity in the Central Atlantic magmatic province, which caused global warming, and a dramatic change in chemistry composition in the oceans is the most likely cause for this mass extinction, which saw the elimination of many amphibian and reptile species that dominated the Earth at the time. This mass extinction marked the end of around 76% of all species at the time. The most recent and famous mass extinction is called the Cretaceous-Paleocene extinction, which saw the removal of 67% of the species existing at the time. The most widely accepted theory is that the extinction was caused by a huge 6-mile-wide asteroid crashing into the Yucatan Peninsula in northeastern Central America, resulting in an immediate and rapid cooling of the planet. A huge blast wave and heat wave went out throughout the world, which threw vast amounts of material up into the atmosphere. It sent soot traveling all around the world. It didn't completely block out the sun, but it reduced the amount of light that reached the Earth's surface. So it had an impact on plant growth. Temperatures were believed to have plummeted by at least 11 degrees C globally. The lack of sunlight would have eliminated plants on land and phytoplankton at sea, which forms the basis of the food chain. If you've noticed a trend within these mass extinctions, that's because there is. Virtually all of the big 5 mass extinctions were due to some sort of major climate disruption, warming or cooling. The worst of all mass extinctions, the Permian, saw a global increase of greater than 10 degrees Celsius, resulting in nearly every living thing on the planet to die out. Now, with all this knowledge, let's take a look at what's happening in the world today in the context of the 6th mass extinction. On average, over the past 65 million years, mammals had an average extinction rate of less than 2 species per million years. But in the last 500 years alone, up to 5,570 species of mammals have gone extinct. This represents an extinction rate that is actually higher than previous mass extinctions. Currently, around 1 in 4 mammals, 1 in 8 birds and 2 in 5 amphibians are at risk. It's important to mention, though, that only a fraction of species have been evaluated, so these numbers are most probably underestimates. A devastating report produced by the Living Planet Index claims that there have been a 68% average decline in wildlife populations since 1970. So let's now look at the criteria for an event to be considered a mass extinction. In order for the current time to be considered a mass extinction, at least 3/4 of all species must go extinct within the next few million years. Since 1500, we've lost up to 1% of species. Simple math would tell us that if it took 500 years to wipe out 1% of species, then it should take us roughly 37,500 years to wipe out 75%. This would be much faster than the previous mass extinctions, which all took hundreds of thousands of years at the very least to occur. This obviously assumes, however, that the current rates of extinction carry on at the same rate, a really big assumption. This is because numerous studies have shown that not only are we losing species, but we're losing species at a faster and faster rate. The background rate of extinctions of vertebrates that we would expect is around 0.1 to 1 extinctions per million years. Modern extinction rates average around 100 to 1,000 times higher than the previous background rate. Things get even worse when we factor in the amount of species that are endangered and not far off from extinction. If those animals were to go extinct, then extinction rates would skyrocket. Since 1500, extinction rates are estimated to shockingly be 24 to 81 times faster than the Cretaceous-Paleocene extinction, the mass extinction that wiped out the dinosaurs. If we look at even more recent rates, from 1980 onwards, this increases to up to 165 times faster. So, in conclusion, if current extinction rates were to continue into the future, we would be very much on course for a 6th mass extinction. Now, with the facts out of the way, let's figure out what are the driving forces behind the 6th mass extinction. The global human population doubled in the past 40 years, reaching just under 8 billion people currently, and is projected to approach 10 billion by mid-century. This rapid explosion of the human population has placed a massive and growing burden on the natural world. According to the International Union for Conservation of Nature, habitat destruction is by far the greatest threat facing all species on the planet, affecting around 9 in 10 species assessed. This was followed by overexploitation, responsible of 26.6%. Then invasive species, responsible for 25%. Then pollution, responsible for 18.2%. And then finally climate change, responsible for around 16.8%. However, it's important to mention that as time goes by and climate change accelerates and becomes more severe, it's highly possible that this graph could change drastically, and climate change could possibly become the biggest threat to all species, as had happened in the previous mass extinctions.